Hello everybody, welcome into another lesson. So today we are going to talk about some very useful properties of logarithms that are actually going to make our lives a lot easier. So we're going to talk about three different properties today. So first you have the power property of logarithms. If you have a log with some base, in this case log base b of u to the n power, so any log with a base of a number to a power, what happens is you bring that power down to the front of the logarithm, multiply it by the logarithm itself. So log base b of u to the n would equal n times log base b of u. You just bring that power down in front of the logarithm and multiply it by the logarithm. And then you have the product property of logarithms. So let's say you have a log of a base where log with a base of the product of two different numbers. That's the same as taking the log of the base of the first number plus the log of the same base of the second number. So log base b of uv equals log base b of u plus log base b of v. And then you have the quotient property of logarithms. So let's say you have a log with a base of a quotient of two numbers. That's the same as the log base of the numerator minus the log of the base of the denominator. So log base b of u over v equals log base b of u minus log base b of v. So we're going to do some exercises, and I taught all three of these at once because they kind of go hand in hand. So let's go ahead and get into these here. So let's say you have something like log base 2 of 4 times 16. So we have log base 2 of 4 times 16. Well, inside of what you're taking the base of, you have a product. So we can use the product property of logarithms to make this log base 2 of 4 plus log base 2 of 16. We were able to separate those with the product property of logarithms. Now, 2 to the what power equals 4? What's log base 2 of 4? Well, that's 2, right? Plus, we got to deal with what's log base 2 of 16. So in other words, 2 to what power equals 16? Well, that'd be 4, right? So this simplifies into 2 plus 4, which would end up giving you 6. So the answer to this would in fact be 6. Alright, we have the ln of e to the negative second. So we have the ln of e to the negative second, a natural log of e to the negative second. Well, again, ln is just log base e, right? But this is a power property, so that power of negative 2 can come down front and you multiply it by the logarithm, natural log of e. What is the natural log of e? Well, e to the what power equals e? That'd be 1, right? So you'd have negative 2 times 1, which would simply give you negative 2 for your answer. So the answer to this would be negative 2. Alright, so we have log base 2 of 4 to the third power. So log base 2 of 4 to the third power. Well, this is a power property, right? That power of 3 can come down front and you can multiply it by log base 2 of 4. So this can be rewritten as 3 log base 2 of 4. Well, log base 2 of 4 is the same as 2 to what power equals 4? That'd be 2, right? So this would turn into 3 times 2, which would just simplify into 6. So you get an answer of 6 for this. Alright, we have, this should be an easy one. Log base 5 of 125. Log base 5 of 125, so 5 to what power equals 125? That's 3. So that one we didn't even need to do anything with. We just get an answer of 3. You could have split it up into log base 5 of 25 times 5, but why? That's really not necessary. Alright, let's see. We have log base 3 of 9 to the 4th power. So we got log base 3 of 9 to the 4th power. Well, this is a power property of log, so that 4th power can come down front and you'll multiply it by the log base 3 of 9. So we have 4 times log base 3 of 9. Well, log base 3 of 9 is the same as saying 3 to what power equals 9? The second power, right? So this would turn into 4 times 2, which is 8. So the answer you should get for this would end up being 8. We have log of 1/10. Remember, if you just see log, that means that by default it's the common logarithm, base 10, right? Well, what is 1/10? Isn't that the same as 10 to the negative first? So you could say log of 10 to the negative first for this. So we get log of 10 to the negative first, which we have a power property now. You could bring that power of -1, multiply it by that log of 10. What is the log of 10? So 10 to what power equals 10? That'd be 1, right? So this would just turn into -1 times 1, which is going to give you -1. So the answer to this one would be -1. We have the ln of 1 over e to the third. So we have the ln of e to the third. Ln of 1 over e to the third. This could be written the same as ln of e to the negative third, right? Well, we can bring that power down front. This would turn into -3 times the ln of e. Ln of e is 1, so this will turn into -3 times 1, which would simply give you -3 for your answer. So the answer to this one is -3. Alright, let's see. We have log of 0.01 to the third power, right? This is really a good one here. So we have log of 0.01 to the third power. Well, first let's simplify by bringing that power down front. This will turn into 3 log of 0.01. Well, what is 0.01? That's 1/100th, right? So this would turn into 3 log of 1/100th. Well, notice something. Log, of course, means the common logarithm with base 10. 1/100th is the same as 10 to the negative second, right? So this would be 3 log of 10 to the negative second. Which means this is another power property, so you can bring that -2 down front. You'll multiply that -2 times 3. That would end up giving you -6 log of 10. So what's log 10? That's 1, right? You'll end up getting -6 times 1, which would just give you -6. So the answer to this should end up being -6. Alright, so let's expand some expressions here. Let's use our product and quotient properties heavily. Let's say we have something of log base 2 of 9x. So we have log base 2 of 9x. Well, we're going to expand this. This is a product property. If we recall the product property, that's the same as log base 2 of 9 plus log base 2 of x. And we really can't expand this any further because 9's not a perfect square or anything like that. There is no perfect number where if you raise 2 to a power, there is no whole number that equals 9. So the answer you should get is log base 2 of 9 plus log base 2 of x. Now we have the ln of 22x. So we have the ln of 22x, which is the same as log base e of 22x. Another product property, so this is going to turn into the ln of 22 plus the ln of x. So this would simplify into the ln of 22 plus the ln of x. Alright, so we have the log of 4x to the 5th. So we have a couple properties going here. We have a product property and a power property. So we have log base 4, we have log of 4x to the 5th, which this is the common log 10. Well, let's start with the product property, which it is first. This would be the same as log 4 plus log of x to the 5th. Log 4 is done, but that log of x to the 5th, now you have a power property. So you can move that power down front of the log of x. So this would turn into log of 4 plus 5 times log of x. And that's the best you could do. So this would turn into log of 4 plus 5 log of x. Alright, let's see. We have log base 6 of x to the 6th power. So log base 6 of x to the 6th power. Well, this is a power property, so that power is going to come down front. This will be 6 times log base 6 of x, or simply 6 log base 6 of x. And that's the best we could get for that. Alright, so we have log base 4 of 4/3. Log base 4 4/3, so now we have a quotient property. So this is the same as taking the log base 4 of 4, which is your numerator, minus the log base 4 of 3. So it's the log of the numerator minus the log of the denominator for a quotient property. However, the log base 4 simplifies further, right? 4 to what power equals 4? That'd be 1, so this would simplify into 1 minus log base 4 of 3. And that's the best we could do with this. So you end up getting 1 minus log base 4 of 3. Log base 3 of 25, well, what do they want us to do with that? There's really nothing we can do with that, so I mean, we're done. There's really nothing we can do with that one, honestly. You could separate into 5 times 5 or 5 squared and do stuff like that, but there's no purpose in it. Alright, let's see. We have log base 6 of 10/3. So we have log base 6 of 10/3. Well, this is a quotient property, right? So this would turn into log base 6 of 10 minus log base 6 of 3. And that's the best we could do with this, unfortunately. So you'll get log base 6 of 10 minus log base 6 of 3. Alright, good one. Ln of 3x y to the third. We have the ln of 3xy to the third, so you actually have 3 products in here. Well, if you have more than 2, the same product property still applies. This would turn into the ln of 3 plus the ln of x plus the ln of y to the third. Well, ln of 3 and ln of x are the best we can do already, but what about that ln of y to the third? Here you have a power property, so you can bring that power down front of the ln of y, so this would turn into the ln of 3 plus the ln of x plus 3 times the ln of y. And that's the absolute best we could do. You get the natural log of 3 plus the natural log of x plus 3 times the natural log of y. What do we have here? Let's see. Is this base 6, I think? No, just base 10. Log of 6x to the third yz. So we actually have 4 products in here. We have log of 6x to the third yz. So we have 4 products. So this will turn into the log of 6 plus the log of x to the third plus the log of y plus the log of z. So we've separated all the products. Everything is simplified except for this log of x to the third, because you have a power property here. So this will simplify further into log of 6 plus 3 log of x plus log of y plus log of z. And that's the best we could do with this. You'll end up getting log of 6 plus 3 log of x plus log of y plus log of z. Alright, let's see. We have the log base 8 of 64 x squared. So we have log base 8 of 64x squared. Well, first we have a product rule. This will turn into log base 8 of 64 plus log base 8 of x squared. Alright. Well, log base 8 of 64 we can simplify. 8 to what power 64? That's 2, right? So you just have 2 plus, now this log base 8 of x squared, you have a power rule, so you can bring down that 2 in front of the log base 8 of x. So this would simplify into 2 plus 2 log base 8 of x. Alright, Alright, we have the ln of x to the 1/2 y to the third. So we have the ln of x to the 1/2 y to the third. Well, first we treat this as a product. Yes, we're going to have some power properties. That should be obvious. But first, let's deal with the product component of this. So this can be written as ln of x to the 1/2 plus the ln of y to the 1/3. Now that we've separated the products, we can deal with the power property. So for each one, bring the power down front. This would turn into half of the ln of x plus 3 times the ln of y. And that's really the best we could get. Half of the ln of x plus 3 times the ln of y. Alright, let's see. Log base 3 of 12 to the 5/6 times x to the 9th. So, we have log base 3 of 12 to the 5/6 power times x to the 9th. Well, first let's deal with the product, right? This is going to be log base 3 of 12 to the 5/6 plus log base 3 of x to the 9th. We've separated it. Now for each of these you have a power rule, right? So this would turn into 5/6 times log base 3 of 12 plus that 9 times log base 3 of x. Now notice, the 12, you have a product of 3 with 12. Isn't that the same as saying 5/6 times log base 3 of 3 times 4 plus then 9 times log base 3 of x. Well, now you have another product rule in these parentheses. This would turn into 5/6 times log base 3 of 3 plus 5/6 times log base 3 of 4 plus 9 times log base 3 of x. Well, log base 3 of 3 is 1, so literally you'll end up with 5/6 plus 5/6 times log base 3 of 4 plus 9 log base 3 of x. And there is the best answer you could get. 5/6 plus 5/6 log base 3 of 4 plus 9 log base 3 of x. So that one was a little bit of a doozy. All right. How about the log of the square root of x? So we have the log of the square root of x. Well, that log, of course, means base 10. But what is the square root of x? Isn't that the same as the log of x to the 1/2 power? Wouldn't that be the exact same thing? Now you just have a simple power rule. You'll bring this down in front. You'll end up with half of log of x. And that's the best way to simplify this. You would end up getting half of the log of x. All right. We have the ln of 3y to the 4th Is that? Yeah, okay. Over x to the third. So we have the natural log of 3y to the fourth over x to the third. Well, we have a quotient rule to start with, so this would separate into the ln of 3y to the fourth minus the ln of x to the third. Now let's notice something. The 3y to the fourth is actually a product. This would turn into the ln of 3 plus the ln of y to the fourth, then minus the ln of x to the third. Well, the ln of 3, there's nothing else we can do with that, so that'll remain the way it is. But that ln of y to the fourth is a power rule. This would turn into plus 4 times the ln of y, and then that ln of x to the third, that's another power rule, so this would be minus 3 times the ln of x. So what you get in the end is the natural log of 3 plus 4 times the natural log of y minus 3 times the natural log of x. Alright, we have log of the fourth root of x to the third. So we have the common log of the fourth root of x to the third, which would be log base 10. Well, okay, what is the fourth root of x to the third? Isn't this the same as log of x to the 3/4? Wouldn't that be the exact same thing? So now you just created a power rule, which you'll bring that down front. You'll literally just get 3/4 times the log of x. And that's the best you could simplify this into. You'll get 3/4 times log of x. Alright, we have log base 2 of the square root of 4x. So we have log base 2 of the square root of 4x. Well, you have actually a power rule. You have a product rule. Remember, square roots you can separate into the separate square roots. So this would be log base 2 of the square root of 4 times the square root of x. Alright, well, you have a product rule now, so this will separate into log base 2 of what is the square root of 4? That's 2, so this will really be log base 2 of 2 plus log base 2 of the square root of x. Well, what is log base 2 of 2? That's just 1, right? Now, what is the square root of x? Isn't that the same as log base 2 of x to the 1/2 power? Which now you just have a power rule, so this will turn into 1 plus 1/2 of log base 2 of x. And that's the best you could do to simplify this. So you have 1 plus 1/2 log base 2 of x in the end. Alright, so we've expanded, now we're going to condense. We're going to go in reverse, actually. So we have log base 5 of 8 minus log base 5 of 12. So now we're going to condense this into one logarithm. So log base 5 of 8 minus log base 5 of 12. So if it's a difference, that means it's a quotient rule. This would turn into log base 5 of 8 divided by 12, which 8 divided by 12 would simplify into log base 5 of 2/3. And that's the answer you would get. This would be log base 5 of 2/3 once you condense this. Alright, we have the ln of 16 minus the ln of 4. So we're going to condense this into one logarithm. Ln of 16 minus the ln of 4. You have a difference of logs, which means it's a quotient. So this would turn into the ln of 16 divided by 4. Well, what is 16 divided by 4? That's just simply 4, right? So you would just get the natural log of 4. And that's the answer you should get. It's the natural log of 4. Alright, let's see. We have 2 log of x plus log of 5. We're going to condense this into one logarithm. 2 log of x plus log of 5. Well, if you have a number in front of a logarithm, isn't that the same as a power rule? So for the first one, you would get, for the first term, you would get the log of x squared plus the log of 5. Now you have a sum of logs, which is the same as a product. So this would turn into the log of 5x squared. And that would be your simplified answer. You would get the log of 5x squared. Four log of 16 base 2. I'm sorry, base 12, excuse me. I read that wrong. Minus 4 log 16 of base 2. Okay. So, to start with, on both of these terms, you have a coefficient, you have a constant, so that becomes a power rule. This would turn into log base 16 of 12 to the 4th minus log base 16 of 2 to the 4th, which in turn, you have a difference of logs would make this log base 16 is become a quotient of 12 to the 4th over 2 to the 4th. But we're not done yet. We got to figure out what 12 to the 4th and 2 to the 4th are. So what the heck is 12 to the 4th? Nope, that's the wrong one. That's 20,736. So this would end up being log base 16 of 20,736 divided by 16. Alright, well, let's see if 20,736 divides by 16. It does. You get 1296. This would turn into log base 16 of 1296. Well, does 16 go into 1296? So, I mean, it does, but this is the best answer you could get because you'll end up having to separate logarithms again if you don't. So this would be log base 16 of 1296. The goal was to condense, not separate. All right. 3 times the natural log of x plus 5 times the natural log of y. So we have 3 times the natural log of x plus 5 times the natural log of y. Well, for each term, we have a power rule, right? This would be the same as the natural log of x to the third plus the natural log of y to the fifth. Now you have a sum of 2 logs of the same base. This would just turn into a product rule, which would give you the natural log of x to the third, y to the fifth. And that's the best we could get, the natural log of x to the third, y to the fifth. Seven log base 4 of 2 plus 5 log base 4 of x plus 3 log base 4 of y. So we have a real good one here. So we have 7 log base 4 of 2 plus 5 log base 4 of x plus 3 log base 4 of y. Well, for each of these terms, we have a power rule, don't we? So this would turn into, for the first term, log base 4 of 2 to the 7th plus 5. No, the 5 log base 4 of x would turn into log base 4 of x to the 5th plus log base 4 of y to the 3rd. Well, 2 to the 7th is 128, so this will turn into log base 4 of 128 plus log base 4 of x to the 5th plus log base 4 of y to the 3rd. Now you just have the sum of 3 logs of the same base, which will turn this into a product rule. You'll end up getting log base 4 of 128 x to the 5th, y to the 3rd. And that would be the best way you could simplify this. Log base 4 of 128 x to the 5th, y to the 3rd. I have about 6 more. Alright, so let's see. We have the ln of 20 plus two times the ln of 1/2 plus the ln of x. Alright, well, for the second term, we have a power rule, right? We have a power rule. That's 2 ln of 1/2. Well, let's write this. Well, the ln of 20 plus that 2 ln of 1/2 is the same as the ln of 1/2 to the second power, which would really be the ln of 1/4 plus the ln of x. Now that we have 3 separate logs added together of the same base, this is a product rule. You'll take the ln of 20 times 1/4 times x. Alright, so what is 20 times 1/4? That's 5, right? Basically, this is just the ln of 5x. So this will simplify into the natural log of 5x. Alright, log base 3 of 2 plus half of log base 3 of y. So log base 3 of 2 plus half log base 3 of y. Well, in the second term, you have a power rule, right? This would be the same as log base 3 of 2 plus log base 3 of y to the 1/2. Now we have a product of logs. Since you have the sum of two logs of the same base, this would just turn into a product. So this would turn into the log base 3 of 2 times y to the 1/2, which is really just the square root of y. So this will turn into log base 3 of 2 times the square root of y. That's what you would end up getting in the end. Four more. We have 10 log of x plus 2 log of 10. So we have 10 log of x plus 2 log of 10. Well, this is going, the second, well, both of them really, we have a product, we have a power rule. So for the first one, the 10 log of x, that would be the same as log of x to the 10th. And then the second one's also power rule. This would be plus log of 10 to the second. Well, now you have the sum of two logs of the same base, which is a product rule. So this will turn into log of x to the 10th times 10 to the second, which is 100. So to simplify this, this would end up being the log of 100x to the 10th. So you get the log of 100x to the 10th. Three more. All right, 3 times the quantity of the ln of 3 minus the ln of x plus the ln of x minus the ln of 9. So this one looks pretty hideous, doesn't it? Okay. Well, let's deal inside the parentheses, right? Inside the parentheses of the first one, you have a difference of two logs of the same base. So that means you have a quotient rule. So this would end up being 3 times the natural log of 3 over x. Plus now you'll end up having in your second set of parentheses, that's another quotient. This would end up being the natural log of x over 9. Right? Look for ways to make it easier first. Now on the first one you have a power rule, don't you? You have a power rule. So you take the first one to the third power. This would be the natural log of 3 over x to the third power plus the natural log of x over 9. Well, let's simplify this 3x to the third power, 3 over x to the third power. This is the same as the natural log of 27 over x plus the natural log of x over 9. Now that you have the sum of two logs, you can apply the product properties, which would give you the natural log of 27 over x times that x over 9. Well, x's cancel out. You just have the natural log of 27 over 9. This really simplifies into the natural log of 3. So the answer you should get in the end is just the natural log of 3. I got two more. Alright, let's see. 2 times log base 6 of 15 minus log base 6 of 5. We have all that. Plus 1/2 of log base 6 of 1/25. Yikes, what a mess, huh? Well, let's deal with the parentheses first. You have a difference of 2 logs of the same base, so that's going to be a quotient rule. This would be 2 times the log base 6 of 15 divided by 5. All that plus half of log base 6 of 1/25. Alright. Well, let's simplify the first one. The 15 divided by 5 is 3, so this would turn into 2 log base 6 of 3 plus 1/2 of log base 6 of 1/25. Alright, so on both of these terms now you have the same base, but you have a power rule. So that 2 log base 6 of 3 can turn into log base 6 of 3 to the second. Plus now that half times log base 6 of 1/25 would turn into log base 6 of 1/25 to the 1/2 power. Alright, so let's simplify these exponents. What is 3 to the second? Well, that's 9, so this would turn into log base 6 of 9. Plus, what is 1/25 to the 1/2? That's the same as the square root of 1/25, which would be 1/5. Plus log base 6 of 1/5. Alright. Now you have the sum of 2 logs to the same base, so that's going to be a product rule. This would simply turn into log base 6 of 9 times 1/5, which would be log base 6 of 9/5. So in the end, you should get log base 6 of 9/5. And I got just one more. Alright. We have 1/4 of log base 5 of 81 minus the quantity of 2 log base 5 of 6 minus half of log base 5 of 4. So what a mess. Of course, let's deal inside the parentheses first, right? Per order of operations, you always want to deal with parentheses. So we'll keep the 1/4 log base 5 of 81. We're going to leave that alone for now. Minus, let's deal inside the parentheses. So for each of these, you have a product rule, right? I mean, you have a power rule. So that 2 log base 5 of 6 is the same as log base 5 of 6 squared. Minus, okay, that half log base 5 of 4 is the same as log base 5 of 4 to the 1/2. Which we can simplify this a little bit further. You'll have 1/4 times log base 5 of 81 minus, all right, what's log base 5 of 6 squared? That's the same as log base 5 of 36 minus, okay, so what is log base 5 of 4 to the 1/2? That's the same as log base 5 of 2. So we've simplified this a little bit now. Okay, well, in the parentheses, you have a difference of 2 logs of the same base, so this is going to be the same as a quotient inside the parentheses. So log base 5 of 36 divided by 2 is simply log base 5 of 18. All right, now we have just a difference of 2 logs. But we have a power rule on the first one, right? 1/4 of log 5 of 81. This is the same as log base 5 of 81 to the 1/4 minus log base 5 of 18. Well, what is 81 to the 1/4? That's just the 4th root of 81, which is 3. So this would be log base 5 of 3 minus log base 5 of 18. Now we just have a simple difference of 2 logs of the same base. You got a quotient rule. So this would be equal to log base 5 of 3/18. Well, what is 3/18? That's 1/6, right? So this would turn into log base 5 of 1/6. And that's the best we could do. In the end, you get log base 5 of 1/6. So that's it for this lesson. Next lesson, we're going to talk about another useful property of logarithms called the change of base formula. So I hope everyone has a great day. Take care.